presently being operationally done in ISRO or from ISRO for various ministries and departments today. And many of these can be switched over to AI-based solutions. There is a tremendous potential for AI to play a very major role in taking these applications, which you will be listening from me in a short while. Basically, Earth observation satellites are quite a few as far as India is concerned, both in the area of land and water as well as in the ocean. In addition to that, we have high resolution imaging capabilities, weather and climate. And as you know that most of these missions are presently the optical imaging missions, even though we did have the microwave missions and also the hyperspectral imaging capabilities. Since they are optical imaging capabilities, we will be exposed to a lot of multispectral data, which obviously enables you to do a lot of processing, spectral data processing, multispectral data processing, and which also enables us to do varieties of intelligent analysis of such data. When we use these set of satellite data, we have a lot of multi-temporal data availability, which enables you to get into the AI in a very big way. When we look at the imaging technologies itself, we started off initially with the push broom technology, and we have mastered the art of stereo imaging capability, which typically gives you pictures which is in the three-dimensional domain. That means X, Y, and Z. And this enables us to understand the terrain much better, in addition to the multispectral nature of the data with respect to the surface of the Earth. And when we are talking about the three-tier imaging capability that we have in ResourceSat, we are talking about wide field sensor, LIS3 sensor, as well as panchromatic imaging capability. And in addition to that, today we are talking about varieties of these kind of multi-tier imaging technologies, which helps you in covering larger swath, medium coverage, or even a very high resolution imaging capability in the same satellite, which enables you to get multiple types of data for varieties of processing capabilities. The other area is this typical side-looking radar imaging capability, which was started off in ReSat 1, and then we had ReSat 2 series of satellites already into the orbit, and we will be looking at continuation of this particular mission in the near future, which enables us to get the data in active mode. That means basically you send the signals down to the Earth and you receive back and process that Doppler data, what we get, and we are able to derive much different type of information as compared to the optical data. Like optical data waits for or looks for the reflected surface information basically from the sun, but this is an all-weather imaging capability where it uses its own pulses to be sent down to the ground and take back. So energy pulses go down, and this all happens in the radar or microwave region, and all-weather capability helps us to penetrate the clouds and get the satellite data at any point of time, day or morning or evening, anytime. When the orbit allows the satellite to be there, the satellite imaging can be done. That's the beauty of the microwave imaging. Recently, we also had the hyperspectral imaging, which was pretty well done, and it has provided excellent data on varieties of surfaces of the Earth. The order of magnitude of data processing is much different here. We are talking about 60 bands, 256 bands in different part of the electromagnetic spectrum, which allows you to generate wide varieties of spectral data, which can be analyzed with respect to non-overlapping regions. In fact, we talk about cube, a data cube, which basically allows us to have varieties of processing capabilities. The normal conventional image processing techniques are much different. It becomes much different when we get into this kind of hyperspectral cube data analysis, which is a different art altogether. We will not be getting into that, but the idea here is that we have large swath, low resolution imaging capability, and we will be seeing more and more of the hyperspectral imaging in the near future. Typically, when we look at the IRS imaging capability, as you see here, one of the important areas which we have been dwelling upon is the image fusion capability, in addition to the terrain mapping and also getting into the topography of information. This is one type of processing which we have mastered the art and able to understand the surface of the earth in a much better way for deriving information. But today, what we are talking about is much different. That is it possible that we can do the data processing in such a way that the intelligence itself can be pulled out from the satellite data? The other challenges in the data processing is how do you dehaze the image? Typically, the atmosphere creates a lot of problems. So we can bring in a lot of AI techniques into these areas of processing where you make the imaging pretty clear. And of course, when you look at the SCAT-SAT data, enormous amount of SCAT-SAT data is available in the archives of ISRO, which enables us to understand the cyclone monitoring related aspects of the cyclone system as such, which enables us to understand, particularly the historical data can be used in a very big way to come out with much. In fact, it's a new challenge, I would say, for AI practitioners to look at the cyclone as one of the typical predictive modeling scheme which can be adopted in the AI. Of course, what you're seeing at the bottom here is the hyperspectral images, which can be again used for varieties of processing, particularly when we are looking at the optical region today. We are looking at unique mapping skills that can be brought. As you can see, the cross-section profiles you are able to get for a particular area, and you can do a lot more. Basically, I will be touching upon the geospatial analytics and e-governance as part of my presentation. In addition to that, a whole lot of applications that comes into the picture. When we look at today, we talk about a governance a lot, and space data and imaging plays a very big role in governance. Like accountability and transparency can be analyzed from space data. We can bring in the equitability and inclusiveness when we look at all types of processes that are happening on the ground that could be seen from the space, and how effectively and efficiently can we manage this from space, and how participatory it can be. And of course, to do these kind of analysis for good governance, you need to be adopting geoprocessing, which is a very unique technology in the geospatial domain, the Boolean algebra, object tracking systems, and of course, the AI, which plays a very major role, is an icon which is being studied in a big way, and a lot of solutions are already made available. All these things can be enabled under the geospatial modeling. And when we look at this particular diagram, which very clearly shows that the policies and reforms literally guides us into e-governance, which obviously meets the end user. But e-governance can use the technology to address the good governance skills through various geospatial technology and governance, and we can enable a whole lot of new ways of looking at things, which allows us to do better monitoring of the government money that is being spent on the ground. The concept of geospatial analytics basically gets into the deriving of intelligence from GIS data as well as from GPS and satellite imageries, and we use the geographic coordinate system and GIS as a main tool. And of course, the geographic models and data visualization tools are very important in doing it. We broadly look at a few important areas of benefits from this. One is extracting the insights when we bring in the AI tools into such kind of processing. And of course, the kind of foresight what we can get by looking at different ways in which the data processing can be done, and we can have very focused solutions because of the quantity of historical data that you have and the strength of the historical data, and it enables us to do excellent decision making. We use satellite imaging. This is very, very important. We also need to bring in the other technologies like GNSS, particularly the global navigation system is playing a very big role, which gets ultimately integrated into GIS. And today, even the drones are playing a very major role. So it is a confluence of the satellite imagery, the GNSS system, as well as the UAVs all get merged into GIS and and allows us to do analysis, and we can put applications of varieties of things like agriculture, energy, etc. And all the spatial domain can be addressed with respect to state, district, block. You can go down to village panchayat level and produce the data that is required for the various kinds of governance requirement. Let us start off with a typical example of land use land cover mapping. ISRO has been doing this particular exercise on an annual basis using AVIF's imaging capabilities. We have more than 15 years of land use land cover maps that has been prepared, which enables us to study how India has been changing or making use of its land for the last 15 years plus. It enables us to do a lot of study on this kind of data, particularly keeping AI in focus. Similarly, the wasteland mapping, we started off way back in 86, 87 onwards. We have multifarious data on the wastelands, and both these are completely a different cup of tea, I would say. Wastelands look at those areas where we would like to do development, where not much development is happening, while land use land cover looks at all the areas including the wastelands and provides a comprehensive picture of agriculture, or it could be urban, it could be rural, it could be forest, water, all that comes into the picture. Typically, when you look at the time series multi-season data analysis, it is a big challenge. What we see, for example, if you look at AVIFs, you may be aware that AVIFs easily covers the entire country of India at least 3 times in a month, because every week you are literally able to cover the entire country. So you can imagine in a year the number of data sets you get, and the way you need to process this multi-temporal, multi-seasonal data sets to come out with an annual land use land cover mapping, which you see here. And once you get that kind of a data, it is possible for you to segregate the Rabi cropping area and the Kharif cropping area very clearly, or you can even look at the comprehensive land use land cover. These are the classes, what you see. And of course, you can have a very detailed analytics of this particular data to understand the dynamics of the land use land cover. It's a major challenge for a country like India. When we look at crops, because as we know that more than 60% of the country, or even 70% of the country depends on the rural masses or the rural produce, which automatically depends on cropping. Today, agriculture sector plays a very major role in providing the food for the country. Crop area, particularly estimation and pre-harvest production estimation. This becomes very important. Today, we have an operational mechanism by which we are able to address 8 crops, and we are able to literally see the different time cropping pattern here. For example, November to March, you are able to see how the crop develops, and this is simultaneous extraction of the ground information. So we have mastered the art of providing the acreage and production estimation for rice, wheat, mustard, sugarcane, and various other crops. And this helps us to have better information available to the government for making plans for even import and export of food grains for the country. A typical example of how multi-temporal data analyzes or provides the input for us with respect to different seasonal perspectives. Of course, with high resolution data like 5.8 meter resolution list 4 data, you can literally go down to the plot level information here. On the waterfront, we have produced an excellent information system for the Water Resources Ministry, which broadly looks at basin level data. The base data onwards, even socio-economic data has been beautifully captured and kept. You have all the surface water bodies, groundwater, hydromet, and even water quality information, snow glaciers, and various other data sets are there. So it's a multi-layer GIS database that exists for the entire country, which could be analyzed for water budgeting, and you can do management of water in a much unique way. When we look at a subset of that kind of a water resources information system for Telangana itself, it is a separate information system called TWRIS, which has been generated and made available to the state government system, which uses it for minor irrigation, medium and major irrigation activities. In fact, the entire 45,000 plus water bodies have been geotagged for the entire state, and we are able to do crop monitoring and the entire water requirements for the crop, particularly from the minor commands and the major commands. We are able to address it using the geospatial technology. So it's a collaborative mapping effort. Literally online mapping has been done using the Bhuvan portal in a very big way. In fact, real-time mapping portal, maybe for the first time it was operationally used on Bhuvan, where new tools were developed, and this online mapping tools has enabled us to get a complete picture of the Telangana water information, particularly the tank ayacuts, which are very crucial for the water release, and the cadastres which actually get the water, how many of the areas are having standing crops, what kind of crops are being cultivated, etc. All that particular information gets captured, and it becomes very easy for anybody to get into the rabi cropped area, the kharif cropped area, the crop wise cropping pattern and things like that. It's a very unique information system. In fact, you can see how the entire database has been captured and kept here for Telangana, and this is a very special focus at the cadastral level where we are able to get the data. So you can go from global to local and provide the information from the Earth observation satellite data, which addresses the tank commands in a very big way for Telangana. Not only that, when we are looking at hydrology, we have a national hydrology project which is being done by the Water Resources Group at NRSC, which basically look at hydro informatics. It's a new area. In fact, all these applications, what I'm talking about, you can look at it from the AI perspective in the future. The present applications, what we are using it, we are using varieties of geospatial technologies, but we can easily get the blend of AI into this particular system so that we can look at the snow melt forecast in a much different way. We can make soil moisture predictions or even evapotranspiration, depending on the kind of prediction models that can be brought in. So presently we are addressing three main themes for the entire Himalayan region here, which addresses even at the country level the surface runoff and evapotranspiration. On the groundwater front, it is a well-known fact that we have a very good tool of Earth observation system and ground data by which we have produced the entire groundwater potential maps for the country. Now the question is, how dynamic are these aquifers and how can we extract information on real-time basis and provide that to the needy people so that people get to know the potential of groundwater at a given point. On the vegetation and biodiversity front, excellent mapping schemes have been adopted, modeling schemes have been adopted to delineate the high rich biodiversity area. In addition to that, biological richness and disturbance regimes have been captured and provided, but AI can play a very major role in bringing out a lot of spin-offs from this kind of databases by bringing in multi-temporal database and information system. ISRO has played a very major role in watershed development programs in the country. This is one example I am quoting for Karnataka, wherein even people's participation has been brought in to address water resources plan and land use, land resources plan, and we integrate multifarious thematic information while doing so. At the same time, we look at the terrain data which comes from stereo imaging from space. So you can see the wide variety of data that is being captured here, in addition to the socio-economic data that comes from the field. It's a typical case for artificial neural network and also for AI to bring in its own capabilities to analyze such data and produce excellent results. And if you are able to track the pre-treatment and post-treatment data, you can see very clearly how developments have taken place. You can see visible changes coming out in the water tank area, where even foreshore plantations have been made by the people because of the abundance of water. The gullied and very degraded lands have been converted into plantations that can be seen. This particular patch can be seen how well it has been regenerated, and this is a typical example of a time series which shows a degraded land has become a rich forest area. So it is possible for you to do land transformation using techniques from space. In fact, because of the success story, the government has adopted it at the country level. Today, we are running a similar kind of a program for 86,000 micro watersheds in the country as part of the integrated watershed management system, and more than 11 lakhs interventions that have taken place have been geotagged and they are available on Bhuvan on the public domain. Because of such stories, today we are talking about NREGA program, which is a major program for rural employment generation scheme. We are able to track the prior, during and post activity tracking using the geotagging techniques, which uses the GNSS model and bring in the space data from the imaging and viewing, and putting these data sets together. It is possible for us to cover the entire area of the country today as an operational program, to see how well such programs of the government can be tracked from both GNSS and space data. On the urban front, you can see very high resolution images of sub-meter, which captures literally rooftops and even small water ponds. And these kind of maps are allowing us, something like 4,000 scale maps are allowing us to get into the program of the government, particularly the Atal mission for regeneration and urban transformation, which looks at how do you do an optimal urban planning for the future. So these kind of high resolution maps are being provided from NRSC for addressing the urban planners to use these kind of high resolution data on a fast track basis. There are a lot of urban areas in the country which need to be very closely looked at from the historical perspective as well as the futuric perspectives. It becomes important that at least in the future we do better planning as compared to what we have done so far. And here is an example of 1965 satellite imagery which shows Bangalore. As and when you get along, you see how urbanization has literally gone all around Bangalore, and it spreads across the municipal boundary and possibly even goes beyond municipal boundary over a period of time. 2007 image, so you have traversed from 65 to 2007, and when you go beyond, you are able to literally see how we are getting away from the municipal boundary. Possibly you need to redefine the municipal boundary, you need to redefine the transport management system, you need to redefine the solid waste management system, the ecological conservation, as well as how we can sustain such kind of an urbanization. So it becomes important that AI tools are brought in a very big way here, because you have a lot of time series data available, and many of these in the urban pockets are dynamic in nature. Today's vegetation you may not be able to find tomorrow because an urban plot would have come up there. So are we doing the right kind of a planning? Is it not necessary for us to adopt AI techniques so that the dynamics of growth of a typical urbanization patch like Bangalore can be addressed in a beautiful way? So time has come wherein AI techniques need to be used for better prediction modeling and to have better urbanization, so that we can address all these parameters effectively. That's the whole idea of such kind of programs. As you know, and I have already told, that it is possible for you to do stereo imaging from space, where we get 3D surface models, and these 3D surface models can be used for virtual fly through a terrain, and you can understand the terrain without actually flying on the terrain, and you can use that particular data for various activities with respect to planning and development perspective. A typical example of Ladakh, for example, you would like to have a 3D perspective. This is a typical example from Bhuvan on the three-dimensional modeling, because it has a very good open source tool which allows you to get into 3D Earth model, and you will be able to visualize various facets of the third dimension of high reaches of Himalayas. Not only that, it is possible for you to estimate the heights of the building. A typical example of an old time image, 2006, where the buildings were not there, and 2015 where buildings are there, and you can easily take the differences of these two images from the stereo perspective, and you will be able to make automatic measurements of the height, which comes out very accurately from the three-dimensional mapping. It's not only that, it is possible for you to build 3D city models. We talked about 2D city urbanization, urban sprawl, but you can literally look at 3D city models, and it is possible for you to plan your 3D city models in such a way that you can get a perspective of the present and the future, and how you can bring in AI techniques here to predict the future of such 3D city models, and how you can accommodate larger and larger urbanization, particularly number of people. See, it's not possible for you to stop the urbanization, but you have to find ways in which you can support urbanization that it is sustainable. That's the challenge which one can address both by 2D as well as 3D imaging capabilities and bring in the AI tools. In addition to that, the mining is yet another major area where monitoring is required. It is possible for you to use the geotagging techniques of GNSS, and this is the beginning time when the mining takes place. Over a period of time, the mining area spreads, but you can always see whether the overland, the debris, whether they are well treated and well put, that can be managed and mapped and monitored. And the futuristic projections of such kind of mines can also be predicted, and the the livelihood environments in the surrounding areas can also be very carefully guarded when we have proper monitoring of these. When we come to 3D GIS analytics, landslides play another major role in high reaches of Himalayas as well as in Western Ghats, particularly in Kerala, Idukki area, where we get into a lot of problems. A typical example of a high reach in Himalaya where a huge landslip has taken place. You can see the debris here and the amount of waterlogging that has taken place. You can imagine if a hole is driven through this, the entire water would flush out through this place, and it would cause a typical flood in India. This could happen. So you can do analytics here. You can estimate the total debris, and you can see how the passage of this water to the other side can be smoothly made, and you can also estimate the area and volume of the heap, so that proper controlled action can be taken for the water to be let out in such area. So these kind of analytics need to be done on geospatial domain, and Bhuvan allows you to have such kind of unique tools and technologies to do such things. Like whatever I have shown you so far, it amounts to the use of such technologies which can use mobiles, which can use drones, which can use 2D and 3D techniques, and you can have live coverages of different types of events, and it enables you to do wide varieties of monitoring of natural resources. There are some very unique features in Bhuvan, because Bhuvan is a platform which can support AI in a very big way, and a whole lot of data and a lot of historical data is already existing on Bhuvan, which is an ideal platform to build an AI-based tool and technology so that the country can get benefited. So we have visualization platform, we have a lot of free data clearinghouse, a lot of free data can be downloaded here. Then, of course, it is housed in a very unique data center. It is a unique platform for disaster management, which I will be talking about. It shares a lot of data on all the states in the country, and it has wide varieties of application capabilities. A typical query for analytics gets allowed onto the system, where you can get the thematic class of a particular GIS, you can estimate area on the flight, and you can use the various types of Boolean algebra to get the exact process data the way you want it and the way you would like to process it. Bhuvan supports the APIs. Of course, we don't have the AI-based APIs today, but some of the typical tools that are available, of course, APIs can be easily developed even by the users. We can use simple Python codes, and we can bring in the APIs, and AI-based APIs helps in a very big way for online data processing, particularly a whole lot of classified data that is available on Bhuvan. So we can get into village geocoding, the reverse coding, as well as the various thematic APIs as well as routing problems are being solved today, with of course standard JSON output possibilities. And you can see also through the WMS Manager, it is possible for you to also get access to Bhuvan and get the visualization perspectives. You can add your GIS tools and you can build varieties of new models by using the Bhuvan tools as well as your tools on the AI front. At the same time, it allows you to do geoprocessing, which helps you to do use the resources of the powerful resources of Bhuvan to do the data processing and fetch you the final results, and that helps in decision making in a very big way. So Bhuvan Planner is another important tool which basically allows you to do the GPS, so the geoprocessing. Some of the typical geoprocessing, what you can very quickly do on the fly is buffering, intersection, union, and various other automatic area calculations and things like that. Not only that, the non-spatial data, the textual information that you have it in the form of census data can be visualized online through simple tools, mapping tools. We have a special GIS Viewer which does the spatial analysis of the census data and provides these unique tools. See, this is very, very important when we blend the satellite imaging data and the socio-economic data to make meaning out of what exactly we are seeing on the ground with respect to the natural resources. So hence, the non-spatial data gets simplified when we bring it out into a mapping tool, and these mapping tools are linked to your geospatial domain. You get the natural resources as well as the census data to make a final judgment of what really needs to be done for a given area. A typical example of how the entire postal department, which is about 1.55 lakh post offices in the country, is literally on Bhuvan today, and they are planning wide varieties of developmental schemes on the location based information. At the same time, you can use mobile based tools. I was talking about mobile as an important tool on Bhuvan. Mobile based tools, particularly using the accelerometer, it is possible for you to do the rating of the roads. How bad or how good is the road, and it also automatically does the mapping. So it is a very interesting tool which enables you to capture the condition of the road, good, moderate, or severe, based on which developmental activities can be done. Accelerometer is simply used in such technology. Of course, this is a 3D viewing tools, especially under the pandemic conditions. Many of you may not be able to get into let us say a museum. If you want to go, this is Salarjung Museum, for example. So if you want to really get into a Salarjung Museum and then see what's there inside, here is an example which has been provided by Bhuvan, which enables you to literally step into the museum and start looking at things. So it is necessary for one to use the new technologies, new tools, and enter into a realm of using such tools for analytics. Obviously, AI will play a very major role. The disaster management, as we have been seeing, has a typical pattern in our country, which is providing, which is clearly showing us the affected area year by year, and especially the Himalayan region and the eastern part of the country gets badly damaged every month, every season of disaster, particularly the floods and cyclones. And of course, in certain seasons, we do have forest fires. Landslides are quite often triggered by very heavy rainfalls in the upper reaches. And earthquakes, of course, they are accidental events that do happen, and agricultural drought do happen quite often in the country. We have an excellent mechanism by which we monitor various types of disasters. This is a typical example of cyclogenesis, where we are talking about the cyclone prediction, how well we can do we have a lot of models which enables you to do cyclone prediction. As I was talking about, here is an example. Here is a very important requirement of the country where we need to have AI tools for the cyclone prediction in a big way, particularly understanding the patterns of the cyclone and predicting them. We all know the kind of disaster that was caused in Kedarnath, particularly when the Chorabari Lake gave way due to giving way of the moraine here. This is the Chorabari Glacier, what you see. This is a three-dimensional shaded relief map which very clearly shows the relief information. The Kedarnath township is here. The water literally pours down to this particular place to cause a very major damage. And when we have such kind of a damage happening on the ground, it is possible for you to also estimate. This is a almost near real-time imagery what you see, and this is the post-disaster analysis of the damage effect. Particularly the red patches, literally they have vanished. They don't anymore remain on the ground because they were washed away, and very heavily damaged ones are shown in blue and partially damaged ones are shown in green. So you can literally do a damage assessment from space data where exactly you are not able to access. When you are not able to go to that place, best way is to use the spatial data analytics and also possibly use AI in the future to see that we have an accurate assessment of the disaster affected area. Another example of Kerala, where we have seen the kind of major flooding that took place and created a whole lot of a problem, and real-time data access was available on Bhuvan, which shows you very clearly the kind of damage that we went through. Before I end, I would like to just give a small introduction to AI, even though it is not part of my talk, but I thought you can keep this in mind when you get into the remaining part of the lectures by others. It is important that we live in a complex real world situation where artificial intelligence, which involves ML and DL in a very big way. We need to bring in our computer vision, particularly the the digital image processing system, the web-based the tools, the virtual reality, augmented reality, as well as the GPU computing. Big data analytics is playing a very major role. See, these are typical combinations which one would like to look for if you want to really make an impact in the complex real world problem solving situation, because you cannot get away from the cloud and edge based computing. You also need to be having traditional ETLs at the same time residing with your system, while you cannot forget about the IoT tools when we are moving into the 5G, where 4G is already left behind. So we are looking at a combination of changing world where AI plays a very major role. This particular workshop will of course be concentrating on this, but I feel that you should not lose sight of the rest of the boxes what I have shown here. You need to look at newer tools, newer technologies, newer platforms, and newer skill sets if we have to adopt ourselves to the changing world. Typically, when we are looking at neural network based processing, initially it started off as simple neural network problem solution, but today it has become a learning curve, a learning tool, wherein we have a whole lot of input layers which gets into multiple hidden layers depending on the way the architecture is taken up, and ultimately you have an output. This kind of a artificial neural network allows you to do better learning, or sort of take you into a deeper learning system because of the multiple hidden layers that does the processing of the data for you and provides the excellent information that is required for you. The deep learning, of course, looks at the object detection. You can get into the pattern recognition area and a whole lot of other areas like image segmentation, which becomes important. Change monitoring becomes very important because deep learning techniques are very hungry. They look at huge amount of data, particularly for data synthesis and detection. So you need to note some of these points when we get into the varieties of data processing, which we will be really doing, especially when we get to the high resolution data, the huge amount of multispectral data, the hyperspectral information what we have, and also the drone data. Some of the typical examples of the object detection techniques are shown here, but I'll not dwell on that. A typical example of how drone data can be used for extracting the roads, a typical example of how feature extraction can be taken up in the UAV domain, particularly when we are using these tools. I would like to stop at this point. I'm not leaving moon. Just now, Dr. Prakash Chavan was talking about moon. We need to look at AI just not on Earth, but also need to look at it in moon also, and surely in the future on Gaganyaan also. Thank you all very much for